Here's warm-up 5.1. We're going to do some factoring. Okay, so let's look at this first problem. I want to see, first off, I'm always checking for a common factor. So I'm thinking, is there anything that goes into x squared, 5x, and 6? There isn't anything, but I'm always checking for that first. And then with a quadratic trinomial like this, there's lots of different ways you can do the factoring. I'm going to do this with a diamond problem. So I'm going to draw an x like this. I'm going to take the coefficient of the x term, and I'm going to put that on top of the x. And I'll take this constant, the number at the end, not attached to an x, and put that on the bottom. Some people have this flipped around, but this is the way I do it. And then I'm looking for two numbers that are going to add to 5, and the same two numbers are going to multiply to 6. So I usually start by brainstorming on the multiplication side. And I'm thinking, how can I multiply to get 6 using integers? I could do 1 times 6, I could do 2 times 3, I could actually do -1 times -6, or -2 times -3. And those are really all the ways that you can multiply to get 6 using integers. And I'm looking for one of those pairs that's also going to add up to 5, and that would be this one. So the 2 and the 3 are what goes on the left and right side of this. And you could switch them. You could say 3, 2, or 2, 3. It doesn't matter. But these numbers, the solution to the diamond problem, are going to help us factor here. So I've got my two parentheses. I know this is going to begin with x in both of these, because x times x would give you x squared, right? If you were foiling this, if you did first, outer, inner, last, that would give you the x squared. So we need to figure out what goes in the back, and that's where these numbers come in. So it's going to be a +2 and a +3. And then I just separate them from the x's with plus signs like that. And then this is factored. And you can always test your answer out by multiplying it back together. By foiling it, it should get you back to x squared plus 5x plus 6. Okay, all right, let's try another here. So there's no common factor with all three terms, so then I'm going to go to a diamond problem like this. The -7 goes on top. Make sure you bring the negative with the 7, that's important. Okay, so I'm looking for two numbers that add to -7 and also multiply to +6. So I've got the same 4 ways, right, that I can multiply to get to. And if I was doing this problem myself, I honestly wouldn't write down all these combinations, but I'd be thinking through them. And then I'm looking for one of the pairs that adds up to -7, and there it is. So this would be -1, -6. Okay, or you could write x minus 6 and x minus 1. It doesn't matter what order you have those factors in, but they have to be those two factors. Okay. Next problem, always looking for a common factor, and when I'm looking at all three terms here, there is something that goes into 3x squared, -18x, and 24, and that is the number 3, so I can factor out a 3. Sometimes I see people just divide everything by 3, and you don't want to do that when this is an expression here. If this were all equal to 0, then yeah, I could divide both sides of the equation by 3. In a sense, you can think of this as dividing. But when I was saying, you still need to have the 3 out there. We're factoring it out. So you can think about dividing this by 3, which would leave you with x squared. I usually kind of think of it as distributing. 3 times something would be 3x squared. Well, that would be x squared. 3 times something is -18x, and that would be -6x. And then 3 times something is 24, and that's 8. So a lot of times I'll see people do this without the 3 out there, but the 3 is a factor, so I don't want to throw that away. Leave that there, okay? And now the trinomial, I can factor that with a diamond problem. So I'm going to use the -6 and the 8. I'm factoring this trinomial here, right? So let's think about ways to multiply to get 8. I got those two or the double negatives. Versions of those two, and I do have one that adds up to -6, and so I should have -2 and -4 at the end of my parentheses there. Okay. All right, this last one's a little different because it doesn't say factor, it says solve. Solve means find the x value that satisfies this equation. And what I'm going to do is factor the left side of it first, but that's not going to be the end of it. Okay, so looking at the left side, there's no common factor there. I can use a diamond problem though. Okay, I'm looking, adding two numbers to get 2, multiplying the same two numbers to get -3. There's really only two ways that you can multiply to get -3 with integers. And to get a +2, I need to use that one. So then this is going to factor into x minus 1 times x plus 3. Okay, if this just asked me to factor the trinomial, I'd be finished, but it asked me to solve. I haven't said what x equals, and now I'm going to use the zero product property. So now when we look, and this is one of the big reasons that we do so much factoring, is that it allows us to solve equations like this. So when you look at this, we have two things multiplied together that equals 0. So I'm going to use the zero product property. Product is means multiplication, right? So if the answer is 0 when I'm multiplying, or the result is 0, then it means it has to be 0 times something or something times 0. One of these two things has to equal 0 for that to equal 0 when you multiply. So that means either x minus 1 equals 0 or x plus 3 equals 0. And then here I add 1 to both sides, so x equals 1. Here I subtract 3 from both sides, and x equals -3. So there's my solution. Another thing I see people do on problems like this when it says solve, they do the diamond problem, and then when they find their combo, they say, oh, that's what x equals. That's not telling me what x equals. That's telling me how to factor this. And then I still have to use the zero product property to get my answer. Okay, that's it for this warm-up. See you next time.